Hello, so this lesson is on Module 2, Topic 3, Lesson 3. We're only going to get to Activity 1. This will be something that we explore today, tomorrow, and there's a third part that will be next week. It'll be next week because we'll be focusing on SBAC, or sorry, not SBAC, map testing for the remainder of this week. Anyways, so we've been talking about systems, right? Systems are two or more equations. We've looked at how to solve systems by substitution, or that's where you plug one equation into the other and then try to find the values for x and y. But then also graphing solutions. That's where we have two different lines, and where they cross, that is the solution or the value for x and y that makes the equation true. So what we're going to look at is systems with one solution, where they cross one time, and no solutions, which means they do not cross if graphed. So we're going to look at this context first, kind of analyze it, and then we'll go through a different context later in this video. Okay. So the situation here, it says Jimmy starts with $64 in his savings account and saves $25 per week. All right, this is for Jimmy. And then separately, Eric decides that he wants to save the same amount also. Eric starts with $25 in his savings account and saves the same amount as Jimmy each week, which is $25 per week. So I'm just gonna, maybe I'll highlight this in orange as well. Okay. So number one, it says write a linear system of two equations that shows the amounts Eric and Jimmy will save. So right, when we write an equation in slope-intercept form, right, just remember when we look at a context, this, right, the b value, the y-intercept, tells us where we begin. That's on the y-axis. And the m tells us how much we move, which is our slope, our rise over run. So think about, like, for Jimmy at least, or Eric, right? How much money are they starting in their savings account, right? For Eric, I guess I'll start with, Eric starts with $25. So y equal to mx plus b, the b part is 25. And he wants to save also $25 per week. So that's the equation y equal to 25x plus 25. And then for Jimmy, he starts with $64. So I'll put 64 over here. And he's going to save, right, they're both saving the same amount, $25 per week. So that'll be y equal to 25x plus 64, right? So m is 25. That's how much we move. That's how much we increase every single week. And we're beginning with $64 in the savings account. Okay. So if you wanted to find out how much Jimmy or Eric had in week 8, right, you would plug in 8 in for x and then figure it out. And then multiply by 25 and add whatever our constant value is. Anyways, so number 2, we're going to create a graph of the linear system on the coordinate plane. So we're just going to graph. We know how to graph, right, our y-intercept and our slope. So I'll start with Eric here. He's starting with $25 in his savings account. So if you look on the x-axis, that is weeks. Y-axis is savings in dollar amounts. And our y-axis is going by increments of 25, even though we have every 50 labeled. So, right, if he starts with 25, this means that at 0 weeks, he has $25 in his savings account. And every single week, he's going to be saving 25. So for the slope, where you typically put this over 1, so this means we're going to go up 25 and right 1. So every 1 week, he has 25 more dollars. So for him, he's going to go up 25, which leaves us at 50, and then to the right 1. So like this. We can continue that pattern, but in the end, right, you can use a ruler, protractor. Let's just make a straight line. Going through those 4 points that I have graphed, this looks just about right. Okay, so this represents Eric. All right, and then for the other person, Jimmy, he saves $64. So $64 is going to be a little bit harder to estimate, right? If this is 50, this is 75. 64 is closer to 75. Maybe we'll say a point like right here. And he's going to be going, right, the same exact, we're going to be going up 25, right 1. So let's put a point somewhere like right, if we go up like a full square here, so maybe somewhere right here. And then to the right 1. So that means it's somewhere right here. I'm going to erase that. And then from there, let's draw that line in. So just connect it and then extend it to the boundary of the graph, something like this. And this is Jimmy. So you can see that Jimmy's line is above Eric's line because he had a little bit of a head start. He had $64 versus Eric had $25. So we're going to analyze this with the other questions that we have. So number 3, what does the slope of each graph represent in the problem situation? The slope represents we'll just say the weekly savings amount, right? And then in parentheses, I'll just put, this is how we interpret our slope, as that's how much we move or how much we're going to save. And then number 4, and I should probably say here, this is $25. And number 4, what is the same for both of these people, and then what is different? So what they both have in common is, we'll just say same, I'll just put that they have the same slope, right, for each graph, and the amount of money each of them saves each week. And what is different, right, what's different is the y-intercept. They both start on different points on the y-axis, and this is where they began. I'll just put begin for current tense. All right, number 5. Typically when you have 2 lines, you try to find the point of intersection. So number 5, what is the point of intersection for this system of equations? So that's where the 2 lines intersect. Now these 2 lines, you may notice, they do not intersect since they have the same slope. So for this, we're just going to say that there is no point of intersection. Right, because the lines do not intersect, so they remain the same distance, right, from each other. So like, right, this, you don't have to draw this part, but I'll put this in red. Like this distance right here is the same thing as this distance here is the same thing as this, like, and so on. You kind of get this ladder kind of formation here. Okay. And then we're going to further analyze this on the next page. So let's move to 336. Okay. So it says the lines you graphed in question 2 are parallel lines, right? Parallel lines are lines that never intersect. So that's we just draw 2 lines as the abbreviation for parallel. Remember that 2 lines are parallel when they line the same plane and do not intersect. So number 6, what do you know about slopes of parallel lines? Slopes of parallel lines, I'll write it out. Slopes of parallel lines, so parallels like that, that's a symbol, abbreviation, are equal. Right, because they're sloped the exact same amount. If I say like the slope of like the 200 hallways is the same thing as the 300 hallways, well, they both have a 0 slope, but right, one is not steeper than the other. Right, it means that you're walking kind of the same pace in both hallways. Number 7, does the linear system of equations for Eric and Jimmy have a solution? Now, on a graph, how you find the solutions where they intersect. So since they don't intersect, that means this has no solution. There's no point where both of them, when they save amounts, there's no single week where they'll have the same exact amount in each account. Okay. Anyways, so we're going to consider this next part. So we looked at it graphically, but we can also look at it algebraically. So I can verify that the system has no solution algebraically. So what they did is they took each equation, right? So we took Eric's equation, y equal to 25x plus 25, and we took Jimmy's equation, y equal to 25x plus 64. They decided to move variables to one side. So let's say they saw that this had a positive 25. They wanted to move it to the left side, so they subtracted 25 here. And they also subtracted 25 here. And what you may notice is this will also equal 0. So what we have left over is this 25 and this 64. We have no more variables. So since there's no variables, there's nothing to solve for. So since we have this numerical statement or sentence or equation, we're left with what's called as a false statement. So this is not equal to, so I'll just put here, this is a false statement. I'll just put false. Okay. So number 8, how do you interpret the final equation in this person's solution to money? Is the final equation always, sometimes, or never true? This is never true, right? 25 will never be equal to 64. That doesn't mean that's our solution, but that tells us that it's a false statement. So we'll say never true. Okay, right, so there's no value for x that will make the equation true, they're weak, where both people have the same amount. So that actually gets to number 9. Will Eric and Jimmy ever have the same amount of money in their savings account? This is no. Right? They will never have the same amount. Okay. And then finally, before we go on to the next page here, I did want to talk about, right, how can you tell if an equation, if a system has no solution? So just down here, we're going to put no solution. I'll put SOL. There's 2 things that need to happen when you're solving a system. The first thing, and we might notice it from Imani's solution, is that the variables cancel. Meaning that there's no x's, no y's, we're just left with numbers. And the second thing is that we're left with, you'll have a true statement. So an example of a true statement is like 2 equal to 2, 10 equal to 10. We're left with a false statement. So if variables cancel and you have a false statement, like 25 equal to 64, we'll put a line through it, does not equal. This tells us that there's no value that will make the equations true. Okay. Anyways, so let's move on to the last page that we're going to focus on today, which is still in activity 1 on page 337. Okay. So this is looking at still savings amount, but we have Eric's sister here. And this, right, the last one was no solution. This one will have some type of solution that we'll interpret. Okay, so it says Eric's sister Trish saved $475 working a part-time job during the first semester of school. She recently quit her part-time job to play on the high school's softball team. She withdraws $25. I'm actually going to highlight withdrawals. $25 each week from her savings account for spending money while she's not working. So spending money to eat, travel, right, other purchases that she just kind of needs to live off. So for number 10, this is write a system equation that represents the amount of money that Trish and Eric will have in their respective accounts. I'm going to start with Eric here. Eric we already wrote earlier. Right, Erica is in orange here. That was y equal to 25x plus 25. And then we graphed that. Okay, so let's write that first one. Y equal to 25x plus 25. And I'll just put Eric. And then for Trish, right, if we're thinking in slope-intercept form, where is she beginning? How much is she moving? Hers is going to be y equal to, the things that we highlighted, withdraws $25. So that's not a plus 25. That would be her making money. She's taking money out, so that's minus 25. So minus 25x. And then she starts here her semester. She has $475 accumulated. So we're going to put that as our B value or y-intercept value. All right. And then this is something that we can easily graph. I'll start with, so number 11, create a graph of linear system on the coordinate plane. So I'm going to start with Eric because Eric, he started with 25 and then he kept Every single week he gained another $25. Or sorry, he saved another $25. Okay, something like that. Typically, I like to continue the pattern instead of just drawing lines because continuing the pattern gives us a more accurate series of points. So, I mean, like I could keep going here. I think that should be right. And I'll just put Eric, right? It's always important to label our lines. And then for Trish starts at $475. So I'm going to put a point on the y-axis, 475. So we have 450, 500. This right here is right in between of 475. Now, the slope for Trish is negative 25 over 1. This means we're going to go down 25 and positive 1, so to the right 1. So I'm going to go down 25, which is just down a square, and then right 1, so like this. So let's just continue that pattern. I'm actually going to put hers in a different color. I'll put it in blue. Let's make all the points and then connect it later. All right, if you kind of like reconsider, maybe you want to, maybe you want to get a protractor or ruler located in the back of the class. Welcome to grab that. And close enough. Okay, you get the idea. We have these points though to solidify what is our line representing as. So number 12. What does the point of intersection of the lines represent? So let's find where they intersect. So we see that the black line and the blue line, they cross right here. So what is that ordered pair? When I write an ordered pair, I like to draw like a vertical line, a horizontal line, because that gives me some things here. Oh, whoops, that's not 7. There we go. 9. All right. So our answer here, the point of intersection represents the, we'll actually write it in words here. So this represents the number of weeks. I'll just put WKS. Weeks that it takes both, we'll say to have the same amount. To have the same amounts saved. Okay, and then here, let's write that out. So that's the coordinate 9, 250, right? 9 is, this is our x value, so x is weeks, so 9 weeks. And 250 is y, and y is represented as savings in dollars. So that tells us, right, 9 weeks, it takes us, or 9 weeks, we both have $250 in our account. Now, although Eric is going up, and, forgot to write this out, Trish is going down here, that's when they have the same amount. Okay, so we proved it graphically. I still want to show how we can figure this out algebraically, right? It's my job as a teacher to give you tools. It's your job as a student to decide which tool is best for you. But number 13, compare the slopes of the lines. These slopes, when they cross like this, they are just the opposite. They're opposites, right? One was 25 versus the other one was negative 25. That's what we mean of opposite. So like opposite of 10 is negative 10. Okay. So number 14, determine the solution to the system algebraically. And that's where we're going to set, since they're both equal to y, right? Y is equal to 25x plus 25. And here we have negative y equal to negative 25x equal to 475. We're going to set both of those things that I circled equal to each other since they're both equal to y, and y represents savings. So for Eric, y equal to 25x plus 25. We're going to find when this is equal to Trish, and hers is negative 25x plus 475. I mean, you could make this simpler, like all 4 of these numbers are divisible by 25. So you could divide each one of these by 25, but I'll just keep it like this. I'm going to drop a line like this. So let's solve the equation. We're going to move variables to one side, constants to the other. I'm going to choose to move variables to the left. So 25x right here, that's already on the left. Let's move this negative 25x there. It's a negative, so I'm going to apply the opposite sign, positive 25x. I'll put it here, and I'll put it here. Okay. Now, at this step, right, 25x plus 25x, 25 bananas plus 25 bananas is 50 bananas. So 50x plus 25 equal to, the only thing that survived here is this thing, is 475. So we have x's on the left. I need my constants to the right. 475 is a constant. It's already on the right side of the equal sign. But let's move this 25. That's a constant. It's a positive 25, so let's subtract 25 to both sides. Okay, that's equal to 0. So we're going to have 50x equal to, if you subtract this, that is 450. Okay, and then we'll divide both sides by our coefficient of 50. I'm going to have to squeeze this in here. This is equal to 1. We're going to get x equal to divide this, we can make this a little bit easier on ourselves. They both end in zeros, so what we're doing really is 45 divided by 5, right? Hopefully that's a math fact that we know, but that is, right, 5 times 9 is 45. So x equal to 45. That's actually what we already determined. We found that 9 is our x value right here. And that this x represents weeks. So this tells us at 9 weeks, we have the same amount. We still have to find what is our y value. So I'm going to take one of these two equations that we started with, either Eric's or Trish. I don't want to use Trish because she has a minus sign and she's got this really, really big number. So let's use Eric's, y equal to 25x plus 25. I'm going to write that. I don't have room, so I'm going to put it over here. Y equal to 25x plus 25. And I'm going to plug that in for x, since it's x equal to 9. Okay, now first thing that we're going to do to simplify this is we're gonna multiply first. So 25 times 9, I want you to think about how much money do you have if you have 9 quarters. Okay, so 4 quarters make $1, right? So that's 100. 8 quarters makes $2, right? So that's 200 cents. So 9 would be 225, or $2.25. Plus this other 25 that we have hanging around. If we add that together, this might look familiar because we're going to have y equal to 250. And that's what I had here from the graph. Okay, so our final answer here, we'll just keep, right, x comma y, x and y. It's going to be 9 comma 225. Okay. Good. So from there, we already answered this. When will Trish and Eric have the same amount of money in their savings account? How much will they each have? So this is just, we're going to say 9 weeks. Both will, in 9 weeks, both will have $250. Okay. Now, here, I know this is a lot of work, but I wouldn't say that this is hard. This is just long, maybe tedious, right? But we know how to do each thing, right? We know how to add 25. We know how to subtract 25. We know how to divide by 50. We know how to plug in a number, right? We know how to multiply and then simplify. It's a lot of stuff, but I think it's a lot of like manageable steps. Okay. Anyways, we're going to end it right there. We'll get some practice via Mathia and maybe other forms, but we'll continue activity 2 and 3 in the next video.